All right, ladies and gentlemen, I want to talk you through a little bit about how to calculate the value of an account using compound interest. Now, compound interest is a lovely, lovely thing. What it means is that if you put some money in an account and it earns interest, then you can earn interest on the new value of your account. And so that's how you end up growing your money over time. Or if it's a bad thing and you owe money and it's compound interest, that means you might end up owing more money out of time. So here's the formula. Absolutely make sure I've got this jotted down. P stands for the principal. So that's the initial amount that you have in the account. R is the interest rate expressed as a decimal. So if it's 4%, it's 0.04. N is the number of times the interest is compounded per year. So sometimes interest compounds daily, sometimes interest compounds monthly or annually, and that's going to be really important. Then your exponent is going to be N, once again, the number of times the interest is compounded per year, and T, which is the time in years. Okay, when you take an assessment on this, you won't need to have that equation memorized. I will provide it to you, but you need to know what each part stands for. So let's take a look at this first account, number 5. In number 5, we have $8,000 of principal. So P is going to be $8,000. I'm earning 5%. So that means my rate is going to be 0.05 because it's expressed as a decimal. It's being compounded annually. Well, annually means it's only being compounded once per year. So N is going to be 1 because it's only happening once per year. And it wants to know how much we have in our account after 6 years. So T is going to be 6 years. So in order to find the value of the account, all we need to do is plug those things in. So we're going to have 8,000 times 1 plus R over N. So I'm going to take my rate over N. So it's going to be 0.05 over 1. And then I need to raise that to the NT. So it's going to be raised to the 1, 6. So if I wanted to rewrite this a little bit nicer, I'm going to have 8,000 times 1 plus 0.05 over 1 is going to turn into 1.05. And then N and T, 1 times 6, this is going to be raised to the 6th power. So when we're putting this in our calculator, we'll take 1.05 to the 6th power and then multiply it by 8,000. So I should have a calculator app up for us. All right, hopefully you can see all this. So I'm going to have 1.05 and I'm going to raise it. Oh dear. I need my other calculator. I need a scientific calculator. So I'm going to have 1.05 and I need to raise it. So I'll take x to the y. I need to raise it to the 6th power. And then I'm going to multiply that by 8,000. So the value of this account is going to be $10,720.70. We'll round up 77 cents. 10,720.77. 10,720.77. So that means if you take your $8,000 and you set it in that account and you don't touch it for 6 years, all of a sudden you're ending up with what? $2,720 more dollars than how you started. The other one I'm going to do here is we are going to talk about number 7 because it's compounded at a different rate. So in number 7, our initial deposit is $500. So P is $500. I'm earning 4%, so my rate is 0.04. I'm compounding quarterly, so that's 4 times per year. So that means N is going to be 4. And then I want to know what happens after 10 years. So T is 10 years. So let's set up our equation. A is equal to 500 times 1 plus our interest rate is 0.04 divided by N, which is 4. And then we're going to take it to the NT. t power. So it's 4 times 10 for my terrible handwriting. So A is going to be equal to 500. Well, 0.04 divided by 4 is 0.01, so it's going to be 1.01. We're going to take it to the 40th power. Okay, see how all of a sudden, because we're compounding 4 times a year instead of just once a year, so we're taking this to the 40th power, so it's going to be a big deal. So let's pull up our calculator. Let's get rid of some stuff. Let's clear out. So we had 1.01, and we need to take that to the 40th power. And then we need to multiply it by our initial deposit, which was $500. And so we've got $744.43. $744.43. So we're going to be equal to $744.43. All right, go ahead and try the other two. Notice that in number 8, we're compounding monthly. And if you're compounding monthly, that means that n is going to be equal to 10. So there you go.